How's it going, teachers? I just want to spend a few minutes. Matter of fact, I'm going to make it less than 15 minutes. If it shuts me off, it just shuts me off. I'm going to shut this one down in 15 minutes. I want to show you a few homework problems, okay? So I've got A through F. I'm going to try to talk about all of them. Let's look at A. It says determine which fraction in each of the following pairs is greater. So we're looking at, come on, pen, work. We're looking at 1/6 squared versus 1/6 to the 7th. Now here's what I want you to notice. These bases, the base of 1/6 is between 0 and 1. So 0 is less than 1/6 is less than 1. Whenever you raise a proper fraction, that's what that is. If the fraction is between 0 and 1 to an exponent, the values just get smaller and smaller and smaller. So even though it looks like something to the 7th ought to be bigger than something to the 6th, not when that number inside is between 0 and 1. Multiply it out and see what I mean. So greater than is what goes in here. Okay? Next problem, let's look at B. So I'm comparing 3/5 to the 12th versus 3/5 to the 8th power. Hey, once again, you would think that something to the 12th would be a larger number than something to the 8th, but not when the inside is between 0 and 1. If you multiply 3/5 times 3/5 times 3/5, that fraction just gets smaller and smaller and smaller. So it turns out 3/5 to the 12th is smaller than 3/5 to the 8th power. Again, because that base is between 0 and 1. Next example, looking at C. All right, so this time we have 5/3 to the 12th compared to 5/3 to the 8th. Now this is different, right? 5/3 is bigger than 1. Now if you raise a number to a power that's bigger than 1, that's just going to get larger and larger and larger. Every time you multiply another 5/3, that number gets bigger and bigger and bigger. So in this particular case, when you raise this to the 12th power, that is definitely going to be larger than when you raise this to the 8th power. Why? Again, because 5/3, the base, is bigger than 1. Example D, what do we have here? So I'm comparing 3/5 to the 9th power to 4/6 to the 9th power. Now look, we got different bases here. Totally different bases, but look what's consistent. The 9th power. Okay? Now let's just compare then, which one is bigger, 3/5 or 4/6? Okay, both of these are between 0 and 1. But if you've got the same base, we really just need to know, well, there's between 0 and 1. What are we going to do here? If you keep raising 3/5 to the 9th, it's going to get smaller and smaller and smaller, but 4/6 to the 9th. So really, which one is bigger? You know, is if you could just compare 3/5 and 4/6. 3/5 is smaller than 4/6. How could we prove that? Right? You could cross multiply. You could find a common denominator. Let's just find a common denominator. So I multiply this guy by 5 over 5. Multiply this guy by 6 over 6. So that is 18 over 30 versus 20 over 30. You see 18 over 30 is smaller. So when you raise that to the 9th, that's going to be a smaller value than 4/6 to the 9th. But this is a different problem than the previous 3 because you've got different bases inside. Let's look at example E. We're trying to compare 32 to the 50th power to 4 to the 100th power. Again, the goal is to do this without a calculator at all. So 32 to the 50th power, is that not, 32 is 2 to the 5th, right? And that's to the 50th power. The 4 to the 100th, we could write that as 2 to the 2nd to the 100 power. I didn't leave myself room. Let's squeeze it down here. 5 times 50 would be 2 to the 250. 2 times 100 would be 2 to the 200. Can you tell which one's bigger? Well, this base 2 is bigger than 1. So when you raise that number bigger than 1 to the 250 power, that's got to be bigger than 2 raised to the 200 power. So see how we did that without a calculator? Let's try another one. So last one, and then I've got one more problem to show you. Negative 27 to the negative 15 power. So I'm going to take negative 27, raise it to the negative 15. I'm trying to compare that to negative 3 raised to the negative 75 power. First of all, these negative exponents are driving me nuts. So let's rewrite this as negative 27 to the positive 15 power versus 1 over negative 3 to the positive 75 power. Now, negative 27, I could write with a base of negative 3. So that'd be 1 over negative 3 to the third. But that is to the 15th power. And over here, I'm going to leave this one alone. Okay, I'm going to have to come back up. I'm going to do this in a different color so it's not so much to look at. This 3 times 15. This is 1 over negative 3 to the 45 power versus 1 over negative 3 to the 75 power. I'm still thinking about this, okay? The negative is bugging me just a little bit. Now, when you have a negative raised to an odd exponent, the negative just comes out, okay? So I could put the negative out front, and I could write this, watch this, as 1 over 3 to the 45th power. On the other side, that negative also comes out front, and I could write this as 1 over 3 to the 75th power. How can I do that? Because when you raise 1 to the 45th or 1 to the 75th, it still just gives you 1. Now, this makes it easier to compare. Remember, if you have a number less than 1 and raise it to a bigger value or to an exponent, then it gets smaller and smaller. So without the negatives, this one is smaller than this one. But when you throw the negative in there, the larger number is the smaller value. So I'm going to argue that that is true. There's a lot going on in that one. You might have to stop and think about that one on your own and come back and just verify. All right, so I have another homework example for you. We're just going to do these one at a time. Let's look at A. So A says 7 to the x is greater than or equal to 49. What they want us to do is solve where x is an integer. The first time I did this, I literally just solved it, but I didn't write my x as an integer, so that's one reason I threw this in here as an example. Now, can I write these with the same base? And I bet you're thinking 49 is 7 squared, right? So 7 to the x is greater than or equal to 7 squared. Does that mean x has got to be greater than or equal to 2? Absolutely it does, because if x is bigger than or equal to 2, then 7 to that power is going to be bigger than 7 to the second power. And this is because the base is bigger than 1. If the base is larger than 1, and you raise the exponent to something bigger, then it's going to get bigger and bigger and bigger. Think about that if you need to. Okay. Next problem. Let's check out B. So we have 16 to the x is greater than or equal to 64. Again, the way to get started on these is write these with a common base. So I can't write 64 as 16 to some power, but I can write 16 as 2 to the 4th. It's raised to the x. And I can write 64 as 2 to the 6th. Now, you know when you have a power to a power, you multiply. So this is 2 to the 4x is greater than or equal to 2 to the 6th. Now again, since this base is bigger than 1, the bigger the exponent, the bigger the entire number. So we know that 4x has got to be bigger than or equal to 6. Now if I just solve this, I'm going to get a fraction as an answer. If x were 1, then that would not be true. That's saying 4 is greater than 6. But if x were equal to 2, that would make that work. That 2 to the 8th power is definitely bigger than 2 to the 6th power. So again, you're not trying to solve for x exactly. You're trying to put an integer there for that value to make the statement true. Let's take a look at C. So we have 6 to the 2x power is greater than or equal to 216. Can you write 216 with a base 6? You might not recognize it, but you totally can. 216 is 6 to the 3rd. So I have 6 to the 2x is greater than or equal to 6 to the 3rd. Now, once again, because 6 is a number bigger than 1, then the higher the exponent, the bigger the overall number. So I know that 2 times some integer has got to be greater than or equal to 3 is the way this is going to have to work out. And if I plug in 1, that's not going to work, right? But if I plug in 2, that would be 2 times 2 is 4 is greater than or equal to 3. So if x was greater than or equal to 2, we've got this covered. Okay, not equal to 2, but greater than or equal to 2. Just like the last one, I put if x were equal to 2. But again, I should have put if x were greater than or equal to 2. So 2 and bigger will work. Again, 2 and bigger will work here. I've only got one more, and I'm happy because I think I'll get this finished before my 15-minute cutoff. 3 to the x is less than 1. So let me write that down. So 3 to the x is less than 1. We need that to be true. Now really, this is just a thinking problem. One way you could think about it, though, if we write these as a common base, you could imagine that you got 3 to the x on the left and 3 to the 0, which is 1, on the right. Again, we need this side to be less than this side. Okay, so I know that x must be less than 0 because we have a base of 3, because we know when you have a base bigger than 1, the higher the exponent, the bigger the number. So I've got to put an integer here, and we've got one. 0 is an integer. So what if we just said x has got to be less than 0? That would make that true. No, because if it was 0, it would be equal, right? So x is less than 0. Yeah, that works. You just said an integer, where x is an integer. We got it. Now, it would be x is equal to -1, -2, -3. So maybe it just wants what they can be. And ... So an integer less than 0 would be -1, -2, -3, -4. Got it? All right, I hope that helps you with the homework. If you run into more that just drive you insane, please let me know. I can make videos for those or address them individually with each of you. So have a wonderful day.